Welcome back. In the last video, we covered data arrays. In this video, let us cover a few other major data types and also understand how to control the working directory for your notebook. We will also look at data frames and specifically how to load some toy data sets that are built into Python. We use these toy data sets for exploration, experimentation, for trying things out, for training and teaching ourselves. So these are very useful. For this video and the next two, we will use the same Jupyter notebook, which is titled Lab 3, Exploratory Data Analysis. Python has several key data types, of which we have already covered arrays in the previous video. Another key data type is data frames that we will spend a lot of time on going forward. But let's look at a few other data types, a couple of minutes we'll spend on that. The first thing I wanted to cover was lists. Lists are collections of objects. These are enclosed in square brackets, and that's how you make out whether something is a list. At this point, I'm going to start sharing my screen. So lists are enclosed in square brackets of this type, and they are changeable collections of elements, which means that the elements can be any other types of Python data, such as strings, numbers, or even other lists. And here is an example of creating a list. We can even have an empty list, and a list does not have to have anything inside it. And we can see that this list is actually empty by running the cell. And we see that this list is empty. We create a list, we call it list1, and it has 4 elements, A, 2, 4, and the string Python. So you see that the different elements of this list, they are all different. They don't have to be the same data type. We can check the data type of any variable by using the type command in Python and putting the name of the variable next to that, like so, in brackets. And let's run this cell and let us see, yeah, this confirms that list1 has the data type list. Similarly, dictionaries are also collections, but they take the format of key value pairs. What that means is that there is a key. For example, we could have a dictionary. Think of it like a table. So you may have, say, name as a name as a key, and then against that you may have name, the actual value, which is this. You may have city as the key, and this may have a value, say New York, and so on. And the way this information is represented in Python is like this. So it is enclosed in these curly brackets of this type, and the key value pairs, they are separated by commas. And the first thing here that you see here, this is the key, and this is the value. Then this is the key, and this is the value. So this dictionary that we have created here, it has 2 key value pairs, and you can look at a particular key and the value contained inside it by just calling it like this, by addressing it using the subscript format like this. So my first key is first, and I can just call it by saying dict1 and first. And again, the best way to check this out is to try this. So I create my dictionary, and this is what the dictionary looks like. And when I look for what is first in my dict1, it has John and Jane as the values inside that particular key. Similarly, something else, which is the next key in my dictionary, has 1, 2, 3, which is a tuple as its contents. Again, we can check the data type of dict1, and it is indeed dict. Next, let us look at sets. Sets are unordered collections of objects. which means you can't reference a particular item in a set by its location index. Then they're enclosed in curly brackets, like here, just like for dictionaries. But you can make out that a set is not a dictionary because you don't see the colons that separate the key value pairs. With sets, you can do set operations, and let's look at some of those. So we are here. We define two sets. Set 1 as a collection of 1, 2, 4, and 5, four numbers, and we create a set from our list that we had created earlier. And let's look at what these contain. So let me insert some blank cells here. Let us see what list 1 contains. It contains, if you recall, A, 2, 4, and the string Python. And at this point, our set 1, uh, it is what we just defined it as 1, 2, 4, and 5, whereas set 2 contains 2, 4, A, and Python. When we do a union of set 1 and set 2, we get all the unique elements that are contained in either of the two sets, which is what we would expect. We can do an intersection just to see what's contained in both of the sets. And again, this would be similar whether you intersect set 1 with set 2 or set 2 with set 1. So you get the same answer. When you do differences, however, you can expect a different answer, and differencing set 2 from set 1 will give you all the elements that are contained uh, in set 2 but not in set 1, which is 2 and 4. And doing a difference of set 1 from set 2 gives us A and Python, because these are not contained in set 1 but are there in set 2. Again, I would encourage you to try these out. The next and the last data type that we will cover for now is a tuple. And a tuple is an ordered collection of objects, very similar to lists, but they're immutable. Immutable means that they cannot be changed. And tuples are contained in regular brackets. So, for example, we can define a tuple uh, as being equal to this collection, or we can put them in this parenthesis. And this is our tuple 1, 3, and 4. Next thing I wanted to quickly cover was managing your working directory. And this is a very basic problem a lot of people struggle with in the beginning. When they are in their Jupyter notebook, they struggle with the file path. And if you're trying to load a file, if you're trying to save a file, it goes off somewhere in your file system and you can't find it, or Python reports an error if you're trying to load a data file. Uh, However, you must know what directory are you operating in. To know that, you normally you import OS, which is a library for operating system type commands, and the get cwd, or get current working directory, that tells you where exactly you are in your file system. Notice that I'm in Windows, so I see the forward slashes, but I see two forward slashes instead of one. And that is because the first forward slash is an escape character for the real slash, so that Python knows that the slash that will follow actually is a slash and is not an escape character for you. You can also type pwd, which stands for present working directory, and you can get what your current working directory is as well. You don't have to do an import OS for that. If you want to change your working directory, you can change it to something else by doing os.change directory, and you can provide the directory path where you want it to go, where you want the default directory to be. And again, this example is from Windows. The R here indicates that all the characters in the string that follows should be construed as literals, which means there are no escape characters. This is exactly what the string should be for my working directory, and I can change my directory to this. And at this point, I can see what if my working directory got changed. I copy this command, put it here, and I see that indeed my working directory is now changed to this that I just specified here. With this, we can now move on to understanding data frames. And we looked at arrays, which are a very useful container for keeping a lot of data across multiple dimensions. However, they suffer from a very fundamental weakness. And that weakness is that in an array, there are no headers or labels of any type. You have to track them outside of the array just to know which column or which row or which dimension means exactly what. And that is where Pandas steps in. Pandas use data frames, and these are spreadsheet like uh, objects where there are rows and columns, and these rows and columns can have names or headings. Pandas data frames are easily converted to NumPy arrays, and NumPy arrays can also be easily converted back into data frames. However, when you do that, you also have to tell Pandas as to what you want the rows and columns to be. If you want to give them labels, otherwise Pandas will just give it some default labels and headings. Let's look at some data frames, and that will make the concept of data frames much more clearer. There are a large number of libraries within Python that come with built-in data sets. Some of the newer natural language processing libraries, they contain a many example data sets. Some of them have hundreds of thousands of toy data sets that are built in that can be used for training models, for experimentation, and for doing different kinds of things. We will look at some of these examples of how you can load some of these toy data sets. So we will look at how to load data from stats models, how to load data sets from R, the Seaborn library, from scikit-learn, and also look at how you can generate your own artificial or synthetic data uh, with certain characteristics using scikit-learn. So first, we are going to load some libraries like so here, and then we can access some of the data sets from stats models. The data set that we will load as an example here is going to be some macroeconomic data that is contained inside of the stats models library. And this is what the data looks like. Now, what you see in front of you, this is a data frame. And the data frame, as opposed to arrays, has only two dimensions, rows, and then you have all of these columns on the top. The rows have these labels. By default, the row labels or the names of the rows, they are called indexes. And the default is it starts with a zero and then goes on numerically, it increases. However, row names or indexes, they don't have to be 0, 1, 2, 3, 4. They can actually be names as well. They could be text, string, or anything you would like it to be. Column names, column headings here, for example, these are text and these indicate what each of these columns actually mean. This is the year, quarter, the real GDP, real consumption, real investment, and so on. At the bottom of the data frame, once you print a data frame by just typing its name, it tells you how many rows and how many columns it has. So it gives you a sense of the size of the data set that you're looking at. Because we have loaded this data from stats models also provides a data dictionary of sorts explaining what this data set is, what its source is, and what the different variables mean. And here I can look at this at what data this is. This is US macroeconomic data from 1959 to 2009, quarter one to quarter three. And here in the note function, I can also see uh, the full data dictionary. So when I saw these column headings, real consumption, real investment, real government expenditure, etc., how would I know what does this even mean? And that is explained here. So real GDP is the GDP in billions, chain 2005. So things that would make sense to someone who is a student of economics, but you can see what the different cells mean. This is one example. You can also import the data sets from the R ecosystem using stats models. So one common example is the empty cars data set. And if you have to load that, you have to provide this command, and this will put the data frame in a variable that you decide. I just chose it to be empty cars, and then we can list empty cars. And empty cars it gives me all of this data. And here you can see that the index is not 0123, but actually is the name of a car. And this has many more rows and columns. Um, this is 32 columns. The describe command gives me some more information on this particular data set. It gives me the count, the mean, standard deviation, and so on, the different percentiles for each of these columns in my data set. And again, we are going to look at this in more detail in a little bit, but right now I'm just focusing on how to load some of these toy data sets. The iris data set is again another very famous data set, and you can print the iris data set. It has 150 observations. There are 5 columns, and it gives you the species of the iris flower, uh, and the sepal length, width, and the petal length and petal width as well. And this is a common data set that is used for the training models for classification problems. In Seaborn, which is a visualization library, there are several data sets available. For Seaborn, we can actually get a list of all the different data sets that are available. And these are all the data sets that are available in Seaborn. Diamonds is a very common data set that is used for exploration and for learning things in Python, and that's something we will be using going forward. So let us load the diamonds data set, and we do so like this. Just like as I specified diamonds to be the data set in my load data set function, I could have specified something else as well, and I could have then listed and seen what that particular data set contains. We look at the top 20 rows of the diamonds data set, and I see that it has a number of columns: caret, cut, color, clarity, depth, table, price, XYZ, several things. Interesting. I don't fully know what these mean, but we will look at that going forward. Similarly, we also can load the MPG dataset, which is miles per gallon, and it gives me the miles per gallon for a number of cars. There are 398 rows, there are 9 columns, and here is the name of the car. And these are interesting data sets to analyze and for teaching yourself and for trying different things out. A huge advantage of these toy data sets is that you don't have to go looking for test data to experiment and to play and to teach yourself. You can just use one of these toy data sets. Even though I keep calling them toy data sets, some of them are fairly serious pieces of work. The diamonds data set, for example, it has 53,000 records of basically there are 53 diamonds of which we know essential attributes and also their price. So it allows us to do a lot of things, including trying to predict the price, try to do regression, analyze the data, split it by caratage, by price, by their size and different attributes. So there's a lot you can do with the toy data sets as well. We can, for example, for the MPG data set that we just loaded, we can see which country did the cars originate in. So we can see that they originated in USA and Europe. Those are the two values that I can see here, but I don't see everything else. And by using the value counts command, which we will again look at going forward, we can see that there are 249 cars from the United States, 79 from Japan, and 70 from Europe. We can also make quick histograms. We can again see the country-wise data as a percentage. Here is a very quick histogram that we can create. This is the geyser data set. This is the waiting time for the Old Faithful's eruption in the Yellowstone National Park. There are 272 rows, there are 3 columns, and we can know whether there was a long wait or a short wait, and what was the amount of the wait in minutes, and how long did the eruption last. So this is a data set that again is more quite interesting. We can also create random data sets. So this is an example of a random data set created from a dictionary, and that dictionary contains random numbers and random choices. And this is again something you can play around on your own, change the numbers here, and create a data frame that works for you. So for example, here is a data set that we created with n equal to 25, and it can be anything else. You can make it 2.5 million or however many that you would like, and you get a random data frame with just random numbers and random choices. Similarly, in sklearn, there are many data sets. Let's load a few of them. Here are examples of all the data sets you can load from sklearn. And of course, you can go to sklearn's website and learn of other data sets that may be there in that library. But let's just look at some of these. We import some libraries, a little bit more code here, but in the end, we get our information in a data frame called vinedf. And what this has is there are 178 rows, 14 columns, and it gives me a wine type and the characteristics of each of these examples of wine or these observations. Generally, the rows are called observations, and the columns, they are called features. We can look at the data dictionary, get more information about it. And this is something you can and should try using the notebook that you can download from the course website. There is another data set, which is the California housing data set. And this data set can be loaded like so with the code right here. Again, once you have the code for doing something you need, you do not need, as managers, as leaders, you do not need to think too hard about it. You can just should feel free to use the code. You should just see what it is doing. And again, I would encourage you to explore the code as well. But here is my data frame. So this is again, even though this is a toy data set, this has 20,000 plus observations of homes in California with their median values. These are prices in hundreds of thousands of dollars, uh, and this is from some decades ago. So it's not more recent data, which is why the homes are not as expensive as you might find them to be in the 2020s. And you can get the data dictionary again through the library, and it provides more details on where the data was obtained from and the provenance of that information. I also mentioned that you can create artificial data using sklearn with certain characteristics, and that is something we will have a quick look at. I could create a data frame like this, um, and really this is the make blobs function. Uh, Most of the code that I've used is standard code, which you can vary according to your needs. So number of samples is 1000. I want three centers, which means I really want data that can be classified into three different groups. So give me three centers. How many features, X1 and X2. And this is my data frame. And this data frame really comes live when you actually plot the information. So if I were to plot it, you can see that I have three distinct groups of information here in the three colors, which are labeled 0, 1, and 2, and this is artificial data. The advantage of generating this artificial data is I can then try to train a machine learning algorithm to classify a given point as belonging to one of these blue, green, or orange clusters. And I can then try to test how good a job my model does in being able to do the same. So some of this artificial data generation can be used for that. With that introduction to toy data sets, we are ready to begin exploratory data analysis. And we will do that in the next video, because this video is already quite long. So thank you for watching, and see you in the next video on EDA.